In the quiet of history, a simple bamboo fan on an old wooden bed marked our first attempt to move the air. Ancient palaces once stood in the sun, designed with corridors to catch the natural breeze, while Egyptian royalty sought relief from handheld fans. From the mist of desert oases to wet curtains in open windows, we learned the cool secret of water. Leonardo da Vinci once sketched mechanical wings to stir the air, while colonial halls relied on the rhythmic pull of fabric punkahs. Along cooling streams, wooden water wheels turned in a steady dance of energy. By the 19th century, the first electric fans sparked to life, echoing the natural rising mist of a quiet mountain lake at dawn. Ice melts slowly under the sun, a silent witness to the cooling power of phase change. Beneath the microscope, we find the complex structures of natural fibers, the primal ancestors of our modern cooling pads. Across shimmering desert heat and lush oases, science began to map the physical laws of evaporation, turning raw heat into a refreshing breeze. Today, 3D blueprints glow on our screens, mapping a future of efficient cooling. Glistening resin beads wait under the factory lights, ready to be transformed into high-tech architecture. As the morning sun hits the automated production line, the doors swing open. We leave the old hand fans behind and enter a realm of total industrial perfection. Robots pour thousands of heat-resistant ABS beads into the feeders, where they melt into a uniform liquid stream. Massive steel molds close with incredible force to shape the main body of the air cooler. Robotic arms pluck the steaming shells from the press, while automated lasers trim every edge with surgical and unwavering precision. The shells are cooled by pressurized air before internal frames are installed to handle the heavy weight of the water tank. Every surface is inspected under fluorescent light for a flawless finish. A protective UV coating is sprayed to prevent yellowing, followed by the installation of heavy-duty 360-degree wheels at the base. Heat presses stamped, water-guiding grooves into the plastic frame, while large-capacity tanks are fitted beneath the body. We prove our quality through mechanical impact tests, ensuring the shell can survive the rigors of any home. After an ionized air bath to remove static dust, functional symbols are silk-screened onto the premium surface. Flexible plastic louvers are installed and tested for their smooth, rhythmic movement across the vents. Fine mesh dust filters are fitted to the outer frame, completing the defensive shell. These finished cabinets now line up on the automated conveyor, a perfect industrial symphony of form and function, ready to receive their internal heart. Specialized cellulose paper is fed into the cutters and pressed into an intricate honeycomb pattern. These layers are submerged in anti-mold adhesives to ensure long-lasting purity. In high-heat ovens, the structures are dried and hardened, creating a complex geometric fortress that will soon transform hot air into a cooling mist of life. Under the microscope, tiny air passages reveal a world of efficient surface area. Robots cut the cooling pads to precise sizes before droplets of dyed water prove their total absorption. A thin film of water spreads across the pad, creating the perfect evaporation field. Every unit is then fitted with a protective plastic border by our robotic team. The cooling pads are nested into the side frames, where air pressure gauges verify a perfect flow through the honeycomb mesh. A final blue protective coating is applied to the exterior by robotic sprayers. We see the natural wood tone finish of the pads, where water soon begins to flow gently along the channels, ready to nourish the air. Pure copper wire is wound onto magnetic cores, fitted with silent bearings to eliminate every trace of noise. Digital sensors verify the dynamic balance of the rotor before lightweight resin impellers are cast for the axial fans. Robots install the blades onto the motor shaft with absolute accuracy, creating a powerful engine of airflow. Motors are tested at peak speeds to verify stability before submersible pumps are lowered into the water tanks. Flexible silicone hoses connect the pumps to the upper water distributors, where we check every nozzle for a uniform spray. This internal circulatory system ensures the cooling pads remain perfectly saturated at all times. Automatic float valves are installed to manage water levels, while aluminum heat sinks protect the motor from overheating. Behind a static steel cage, the drainage valves are fitted to handle wastewater. As the pump and fan awaken together, a powerful stream of air begins to flow through the wet honeycombs, delivering a sudden, refreshing drop in temperature. SMD components are fired onto smart control boards, where microchips programmed for natural and sleep modes are secured. A moisture-proof epoxy coating protects the electronics from the humid environment. We install LED displays and touch-sensitive buttons, linking the central brain to the temperature and humidity sensors of the room. Negative ion generators are fitted into the vents to cleanse the air, and the system is powered on for its first digital breath. Inside anechoic chambers, we measure the whisper of the wind, ensuring total silence. We test the Delta T cooling power and the responsiveness of the remote control, proving our engineering is as smart as it is cold. Pumps face 72-hour endurance trials, while UV lights search for the smallest leak in the body. Automatic shutoff systems protect the motor from overloads before every unit is deep cleaned. Once the technical labels are applied, robots nest the machines into protective foam and seal the cartons, sending our promise of health out to the world. Digital graphics reveal a world where purified, humidified air fills the modern living room. Sunlight shines through the cooling breeze, while Wi-Fi connectivity links the machine to the smart home. We look toward a future where solar energy powers the dream, integrated seamlessly into the very top of our sustainable designs. Ocean recycled plastics form our future shells, while biodegradable cooling pads respect the Earth's cycle. We protect the eyes and skin from the dryness of the heat, creating a healthy environment where children sleep in total peace. The silent motors of the next generation move the air without a sound, a ghost of comfort for your home. High-density filters trap every speck of dust as our automated factory pulses in the evening light. Green LEDs signal safety and energy efficiency, a testament to a world where we consume less to cool more. We bridge the gap between man and nature through the simple power of water, creating an ergonomic sanctuary for the modern family. From 3D blueprints to the reality of human life, our design merges into the fabric of your home. The factory falls silent under the night sky, its mission complete. A final cool breeze glides across the lamps, a symbol of life and wellness. Natural cooling for a better world. Every breath you take is a promise of purity and life.